Hello students, welcome to Anne's classes. We are doing algebraic expressions, chapter 11, exercise 11a from the new book, the revised one, NEP 2020 aligned. So let's begin this. So here, exercise 11a is on page number 143 and the first question is the multiple choice type. Choose the correct answer from the options given below. So the first question is the sum of these three polynomials. So here we have 1, 2 and 3. The sum means when we add up these three, which one of these options is our answer is the question. So let's add this up. So here we have a minus b plus ab. This is the first polynomial. To this we're going to add the second one, which is b minus c plus bc, and then we're going to add the third one, which is c minus a plus ca. So now let's open the brackets. So here it is a minus b plus ab. Now we're going to open the other bracket. So because we have a plus sign, these signs remain the same. So this becomes plus b minus c plus bc. Similarly, in the third expression also, here we have a plus sign. So these will remain the same, no change. So plus c minus a plus ca. Now we have to look for the like terms. So here we have an a. Now let's look and see if there's another a. So here we have another a minus a. So can you see a minus a? Let me write that down. So that will be a minus a. So we have taken a. Now let's take the b's. Here we have minus b plus b. That's it. So let's write it down. Minus b plus b. Then let's take the next one, plus ab, and we don't have another ab, isn't it? So let's write that. So that will be plus ab. Then we have minus c and plus c. So let's write that down. Minus c plus c. Then the next thing is plus bc. We don't have another plus bc. So let's write that. Plus bc. And then we write down plus ca. Plus ca. Now let's look at all the like terms. A minus a, that is 1 minus 1 is 0. So this gets cancelled. Here also minus b plus b. So here it is again 1 and 1. 1 minus 1 is 0, cancelled. Now we have AB by itself is nothing else. So let's write that in our answer, AB. Now let's go to the next one, minus C plus C again. This is 1 minus 1, which is 0. So this gets cancelled. Then the next one is plus BC. We'll write that because that's the only one. And the last one is plus CA. So plus CA. So what is our answer here? AB plus BC plus CA. So which of these is our options? As you can see, option C is AB plus BC plus CA. So option C is our answer. Question 2, here we have three polynomials and we have to add them. So let's start off with the second step. The first step is this. In the second step, we are removing all brackets. And because we have a plus sign before these brackets and a plus sign before these brackets, the sign of all the terms inside will remain the same. So let's write that. So that will be x cube minus 5x squared plus 7. Now the next set of polynomials, no change in the sign. 3x squared plus 5x minus 2. Then we have plus 2x cube minus x plus 7. No change. Now let's look out for the like terms. We have an x cube here and a plus 2x cube there. So let's write that. So this is equal to x cube plus 2x cube. Now let's look for the x squares. So here we have minus 5x squared plus 3x squared. So let's write that. Minus 5x squared plus 3x squared. Then we have the whole numbers. Plus 7 minus 2 plus 7. So let's write that. Plus 7 minus 2 plus 7. Then we have the x. So here we have plus 5x and minus x. So plus 5x minus x. So here let's see what we have. X cube and 2x cube like terms. So x is 1 here. 1 plus 2 is 3. So this is equal to 3x cube. Now let's go to the x square. So minus 5 plus 3, that is minus 2. Minus 2x square. Then here we have plus 7 minus 2 plus 7. Okay, we can do it straight away. 7 minus 2 is 5. 5 plus 7 is 12. So here we can write plus 12. Then let's go to the last one. We have 5x minus x. That means 5 minus 1, which is 4. So plus 4. 4x, that is 4x. Now let's write this in order of the powers, descending order. 3x cube minus 2x square plus 4x plus 12. So this is our answer, and which of these is the options here? So 3x cube, they all have 3x cube. Then we have minus 2x square. So here we have minus 2x square and minus 2x square. So one of these is the answer. Then we have plus 4x. Here we have plus 4x. Here we have minus 4x. And then we have plus 12. So answer A is the correct option. Question 3. So here we have a polynomial and minus another polynomial. So we're going to remove the brackets and write. Remember, here there's a minus sign. That means the sign of all these terms inside will change. So let's begin by writing the first polynomial. X to the power of 3 minus 5x square plus 3x plus 2. Now we are going to write the second polynomial by changing the signs of all the terms inside. So minus 6x square plus 4x cube minus 3x minus 5. Now let's look for the like terms. Here we have an x cube, and if you go down you can see plus 4x cube. Let's write that. So this is x cube plus 4x cube. Now let's look for the next one. Here we have minus 5x square, and here we have minus 6x square. So let's write that minus 5x square and minus 6x square. Then let's look out for the x. So here we have plus 3x and minus 3x. So let's write that plus 3x and minus 3x. Then we have the whole numbers plus 2 and minus 5. Plus 2 minus 5. So here let's work on the like term. So here this is 1. 1 plus 4 is 5. So this will be 5x cube. Now let's work on the x square. Minus 5 minus 6 is minus 11. Signs are the same, so we put the same sign and we added x square. Now let's take plus 3x and minus x. 3 minus 3 is 0. It gets cancelled. Then we have 2 minus 5. Signs are different. Put the sign of the bigger number and subtract 5 minus 2 is 3. So what's the final answer? 5x cube minus 11x square minus 3, which is option C. Question 4. P minus in brackets P minus Q minus in brackets Q minus P is equal to which of these? So let's work this out. So let's write that once more. P minus in brackets we have P minus Q minus Q minus, again we have Q minus P. So let's open brackets first. So P minus. Now when you have minus, the signs of all the terms inside will change. Remember, minus P plus Q. Then continue by writing minus Q. Here also we have a minus sign before the bracket. So the sign of all these terms will change because of this. So what will we get? We get minus Q plus P. Now we have a number of P's and Q's. So let's pick them out carefully. So we have plus P minus P and we have plus P here. So let's write that. So that is P minus P plus P. Then here what do we have in the Q's? We have Q minus Q minus Q. So let's write that plus Q minus Q minus Q. So now here what do we have? P minus P is cancelled, isn't it? 1 minus 1 is 0. So we only have 1 P left. So let's write that. Then let's go to the Q. Q minus Q is also 0. So we have only 1 minus Q left. So this is P minus Q. So our answer here is P minus Q, and which option is that? The option is option B, P minus Q. Oh, question 5. Here let's open the brackets for all these. So let's begin by writing this. AB minus BC remains the same. So AB minus BC remains the same. Now we're going to look at this. Since we have a minus sign before the bracket, change the sign of all the terms inside. So plus CA will become minus CA and minus BC becomes plus BC. Now let's take the next one. Here the sign is plus, so no change of the terms inside. So that is plus CA minus AB. Now look for the like terms. Here we have AB and then we have a minus AB here. Let's write that down. So this is equal to AB minus AB. Then let's look for BC. Here we have minus BC and plus BC. So let's write that minus BC plus BC. Then last one we have minus CA plus CA. So that is minus CA plus CA. So as you can see, AB minus AB is 1 minus 1, which is 0. Next one, we have minus BC plus BC. So that is 1 minus 1, again 0. Same thing here, minus CA plus CA, 0. So our answer here is simply 0. Which option is that? Option D. Separate the constants and variables from the following. Now here we've been given a set of numbers and letters. From these we have to pick out the constants and separate them from the variables. Now we have studied constants and variables from class 6 onwards, isn't it? Now let's quickly revise what it is. A constant is a symbol which has a fixed value. So anything whose value will not change is called a constant. Now suppose I take the number 2. Now suppose I take 2, wherever I put 2, it's going to remain the same. This value, if I put it somewhere else, it does not change to 3 or 4 or 5. It has a fixed value. So anything that has a fixed value is called a constant. So first what we'll do is, we'll write down all the constants. We'll pick out all the constants from this. So here we have the constants to be written here. Now look at the first one, minus 7. Now the value of minus 7 will remain the same wherever it is. So that is minus 7. So that is a constant. Now look at the next one. Here we have 7 plus x. Now here x does not have a value given here. The value of x can keep changing. So x is called a variable. Okay, so what are variables? A symbol which does not have a fixed value. So here I can say x is 1, or I can say it's 2, or I can say it's 3. So the value of x keeps changing. So if you have a constant and a variable together, it becomes a variable. Now let me just explain that. Now suppose now that given to us is 7 plus x. Now here if I say x is 1, then it will be 7 plus 1. My answer will be 8. Now suppose I say x is 2, then my answer 7 plus 2 will be 9. Now suppose I say x is 10, then 7 plus 10 will be 17. So can you see that the answer is changing? It's a variable. So if I have letters by themselves, it is called a variable. Or if I have a letter that is a variable and a constant together, they still become variables, as you can see in this example. So that means a number by itself alone can be a constant, but if it is along with a letter, it is a variable. So let's write down the variables also. So here we have 7 plus x. So we finish with this. Next one, 7x plus yz. Letters are there, so it is a variable. So 7x plus yz is a variable. Now root 5 is by itself. It doesn't have a letter, so this is a constant. Now root xy. Now root xy is a variable. Now here 3yz by 8. Now whenever you have letters, remember that will be a variable. 4.5y is a variable. Minus 3x is a variable. Though it has minus 3, when it comes along with a letter, it becomes a variable. 8 minus 5, there is no letter there. So that is a constant. 8 minus 5 will be 3. So it is a constant. Next one, we have 8 minus 5x. That is a variable. 8 minus 5x. 8x minus 5y into p. 8x minus 5y into p. There are a lot of letters there, so they're all with there. So that is a variable. Now here 3y square z divided by 4x is a variable. 3y square z divided by 4x. This is a variable. Question 2. Write the number of terms in each of the following polynomials. So we have all these polynomials here. We have to write how many terms there are in these. Now these are all called terms. This is one term, this is another term, this is another term. Now we have to write how many terms are there in these. Now here let's be careful. Remember, only when terms are separated by the plus or the minus sign can you consider them as separate. So here 5x squared, this will be one term. Okay, because we have a plus sign after that. Then here we have a multiplication sign. That means 3 into ax can be written as 3ax. Can you see? That has now become one term. So totally how many terms do we have? We have 1 plus 1. We have 2 terms. So just look out for the plus and minus sign. There is 1 plus sign, so there are 2 terms. Let's go to the second one. Here we have ax divided by 4 minus 7. So only one minus sign is there. It should be a minus or plus sign. Don't look at the other signs because this plus or minus sign will separate the terms. So how do we write this? Ax divided by 4, we can write it like this. Ax divided by 4. So now can you see this whole thing has become one term? So we have one term here and one term here. We have 2 terms. So this 1 minus sign, that means there are 2 terms. Let's look at the third one. Ax minus, so here let's circle this, by plus y into z. So don't look at the multiplication sign, look only at the plus and the minus signs. So this is one term, this is the second term. Now y into z can be written as yz. So this has become one term. So totally we have 3 terms here. Next one, 23. Then we have plus sign. Then we have multiplication and division. That's it. We don't have any more plus or minus signs. That means 23 is one term and all these together will become another term. A into B can be written as AB divided by 2. So now this whole thing has become one term. So we have 23 and then we have this. So 1 plus 1, 2 terms. Question 3. Separate monomials, binomials, trinomials and polynomials from the following algebraic expressions. So we just answered a question on counting the number of terms. Now suppose an expression has only one term, it's called a monomial. If it has 2 terms, it's called a binomial. If it has 3 terms, trinomial. Now if it has more than one term, it can also be called a polynomial. So let's pick out all the monomials, binomials and the rest from this. Let's look at the first one. So let's write down monomials. Then we have, remember monomials has only one term, binomials 2 different terms, trinomials have 3 different terms and polynomials more than one term. Okay, so let's pick out and see. So look at the first one. 8 minus 3x. How many terms are there? There is one minus sign, so there are 2 terms. So that is a binomial. So let's write it under binomial. 8 minus 3x, 2 different terms. Look at the next one. xy square is by itself. That's only one term. So let's write that as monomial xy square. Now look at the next one. 3y square minus 5y plus 8. Look only for the minus and the plus signs. We have one minus sign, one plus sign. So there are 2 signs like that. That means we have 3 terms. What are the 3 terms? This, and this. So that becomes a trinomial. 3y square minus 5x plus 8 is a trinomial. Look at the next one here. Here we have this whole thing. Now let's count the number of terms. So here we have one minus sign, one plus sign, one minus sign. Totally we have 3 signs. That means there are 4 terms. What are they? These 1, 2, 3 and 4. 4 terms means it will be a polynomial. More than one term is a polynomial. So let's write that first here. 9x minus 3x square plus 15x to the power of 3 minus 7. Let's look at the next one. 3x into 5y. Now we don't have a plus or a minus sign. Okay, that means I can make this one term. How can I make this one term? Multiply 3x into 5y. 3 into 5 is 15. X into y is xy. So now we have 15xy, which is just one term. So if it is one term, it is a monomial. So that is 15xy. So 15xy is a monomial. So instead of writing 15xy, we'll write the question that is given to us. What is the question given to us? 3x into 5y. So that is a monomial. Next one, 3x divided by 5y. I can write it as 3x divided by 5y because there's no plus or minus sign in between. So this is a monomial. So let's write that 3x divided by 5y. That's a monomial. Let's go to the next one. 2y divided by 7 plus 3x minus 7. Look out for the plus and minus signs. There's one sign here and one sign here. So two signs means three terms because 2y divided by 7 can be written like this. 2y divided by 7. Then we have plus 3x minus 7. So how many terms do we have now? 1, 2 and 3. So it is a trinomial. 2y by 7 plus 3x minus 7. And the last one here, 4 minus ax square plus bx plus y. So look out for plus and minus signs. 1, 2, 3. That means there are 4 terms. So that will come under polynomial. So that will be 4 minus ax square plus bx plus y. Okay, we've written everything. But remember, what is a polynomial? It has any expression which has more than one term. That means all the binomials will be polynomials. All the trinomials will also be polynomials. So I can write it down here. So let's write down the binomial. So here we have one binomial 8 minus 3x. So 8 minus 3x is also a polynomial. Let's take the trinomial. So I have one here. Let's write it down. 3y square minus 5x plus 8. And there is one more. Let's write it down. 2y divided by 7 plus 3x minus 7. So all these are polynomials. If there is more than one term, it's called a polynomial. So the monomials will not be polynomials because they have only one term each. Question 4. Write the degree of each polynomial given below. Now what is the degree? The highest power of a variable is called the degree of the polynomial. So in all these polynomials, for each question you have to look out for the highest power of the variable. That means here we have two variables, isn't it? X and y. We have one of x and one of y. So 1 plus 1 is 2. The power of this term is 2. Here we have only one z. So here we have 2 and 1, which is the highest power. 2 is the highest power. So our answer is 2. It's a simple one. Okay, it's easy to find the degree. So look only for the variables, not the numbers. So here we have 2 and here we have 3, which is the highest? 3. Here we have only 1, here 2 and here 8. So the highest power is 8. Now here we have x, y, z. You can add up the powers. So 1 plus 1 plus 1. So that will be 3 and we don't have anything else here. So the degree here is 3. Now here we have 1 plus 1, that is 2. Then 1 plus 2, that is 3. Then 1 plus 3, that is 4. You can add up these variables here. So now we have 2, 3 and 4 and the highest is 4. Here we have 5 plus 7, that is 12. Here we have 3 and 4 plus 4, that is 8. So we have 12, 3 and 8 and the highest is 12. So this is how we write the degree of polynomials. Question 5. Write the coefficient of. So here, write the coefficient of AB in ABX. What is the coefficient? Now, if I give you an example, now suppose I say 2 into x into y. What will this give me? 2xy. So here, 2 and x and y are known as the factors and 2xy together is known as the product. Okay, so these are the factors which give us this product. Now in this 2xy, this is a term which is also known as an algebraic quantity. From this, if I have to find the coefficient, now I only take control of a monomial. So if I have to find the coefficient of 2 in 2xy, I leave out 2 and I write the rest, it becomes xy. If I have to find the coefficient of 2xy, I'll leave out x and write the rest, which is 2y. If I have to find the coefficient of y alone, then I leave out y and write the remaining, which is 2x. So this is how we get the coefficient. So let's look at the first one. Write the coefficient of AB in 7abx. So take this AB, leave out that here. So if I leave this out, what do I have left? Only 7x. It's very simple, isn't it? Now look at the next one, 7a. Leave out 7a and write the rest, which is bx. Next one, write the coefficient of 5x square in 5x square minus 5x, which is a binomial. Now, whenever we are talking about the coefficient, we are talking only about that one term. We are talking only about that one term. So, let's look at this and write in 5, the coefficient of 5x square in 5x square. That means I have to take out this whole thing. So, what do I have in that place? I just have 1. So my coefficient in that question is 1. Look at the next one. Coefficient of 8 in this whole expression, in this polynomial. Now I don't have 8 here, so I don't have to look at that. I don't have 8 here, I don't have to look at that. Here I have 8, so let me look at this. So what is the coefficient of 8? Leave out 8 and write the remaining, which is minus ax. Now next one, 4xy. Find the coefficient of this in this polynomial. In the first term, 4xy is not there. In the second term, it's there. In the third term, it's not there. So leave that out. Look only at this. So what is the coefficient of 4xy in minus 4xy? We cancel out everything. And what is left is minus. So it's minus 1. So this is how we find the coefficient. Page number 140. Question 1. Evaluate. So here we have minus 7x square plus 18x square plus 3x square minus 5x square. As you can see, the literals are all the same. X square we have. That means they're all like terms. Now to evaluate this, you can straight away do it like this, or we can group the minus signs first and then the plus signs and do it. So let's do it that way. So let's start by taking first minus 7x square, then take the next one, that is minus 5x square. So I've grouped the minus signs together. Then continue with the plus signs, 18x square plus 3x square. So here we're going to work this out. I'll just do one or two sums here so it becomes easier for you. Minus 7x square minus 5x square. So what we do is we take only the numbers minus 7 minus 5 and we have the literal outside, that is x square. Now look at this. Minus 7 minus 5 signs are the same. So we put the same sign and we add 7 plus 5 is 12. So we get minus 12 and we write x square. So here we have minus 12 x square. Let's go to the next one. We have plus 18x square plus 3x square. So here also let's take only the numbers plus 18 plus 3. These are the numerical coefficients and let's put x square outside. Now here look at the signs. The signs are the same, plus and plus. So 18 plus 3 is 21 and we write the x squared there. So here what do we have? Plus 21x square. So now here we have minus 12 x square plus 21 x square. So let me just write it down here. So here we have minus 12 x square plus 21 x square. Take only the numbers minus 12 plus 21 and put the x square outside. Now look at the signs. One is minus, one is plus. When signs are different, we put the sign of the bigger number and we subtract 21 minus 12. That is 9. So we write 9x square. So here we've got our answer plus 9x square. So this is our final answer. So this is one way you can do it. You can group the minus signs together and the plus signs together and work it out. That makes it easier. Question 2. First thing you need to do is check whether they're all like terms. As you can see, here we have b square y, b square y, b square y, and again b square y. So they're all like terms, so you can add or subtract like terms. So let's group all the plus signs. Now the first term doesn't have a sign, it's understood it is plus. So let's take that, so that is plus b square y. The next one is this, plus 2b square y. Now let's take the minus signs, minus 9b square y and minus 5b square y. So we've got the plus signs together here. So let's work out this. Now here there's nothing here. It's understood it is 1. So let's simply put 1 there to make our work easier, to understand it better. So now add up the numerical coefficients. That means only the numbers. So 1 plus 2 is 3. So that is 3b square y. Now let's go on to the minus signs here. So when signs are the same, we put the same sign. Okay, so put the minus sign and we add the numerical coefficients, that is the numbers. 9 plus 5 is 14. So that is 14b square y. So now again we have plus 3b square y and minus 14b square y. As you can see, the signs are different. So when signs are different, we always put the sign of the bigger number and we subtract. So here what should we subtract? 14 minus 3. 14 minus 3 is 11. 11 and write the literals, that is b square y. So what is the final answer? Minus 11 b square y. Question 3. So here also we have like terms, so we can add and subtract. Let's group all the plus signs and the minus signs. So the first one doesn't have a sign, it's understood it is plus. So here we have plus a bx, then here we have plus 32, plus 32 a bx. Now let's take the minus signs, minus 15 a bx and minus 10 ABX. So here the first one doesn't have a number, it's understood it is 1. So now let's add up the numbers. So what are the numbers? 1 and 32. So 1 plus 32 is 33. So that is 33 ABX, and that's a plus sign, it's understood. Now let's go to the minus signs here. So both the signs are minus. When signs are the same, we put the same sign and we add up. So what are the numbers we are adding? 15 and 10. 15 plus 10 is 25 and we write ABX. So now here we have 1 plus sign and 1 minus sign. And look at the numbers 33 and 25. Which is the bigger number? 33. So when signs are different, put the sign of the bigger number. That means the answer will have a plus sign. And then you subtract the 2. You must subtract 33 minus 25. That is 8, isn't it? So 8 ABX. So our final answer is plus 8 ABX, or you don't even have to put the plus sign. It's understood. 8 ABX is our final answer. 7x minus 9y plus 3 minus 3x minus 5y plus 8. So we have different terms here, some unlike terms here. So let's group the like terms together. That is, we'll begin with 7x. Let's look at another term which has x, that is 3x. So let's group 7x minus 3x. We'll put them together. Now let's put the y's together. So here we have minus 9y and here we have minus 5y. Now let's take only the numbers, the constants, plus 3 and here we have plus 8. Now let's work on the like terms. We can only add or subtract like terms. So 7x minus 3x, this is the plus sign. Signs are different, so put the sign of the bigger number and subtract 7 minus 3. 7 minus 3 is 4, so that makes it 4x. Now let's go to the next one, the y's. Minus 9y minus 5y. When signs are the same, can you see signs are the same? When signs are the same, we put the same sign. That is, we write minus and we add up these two numbers, 9 plus 5, that is 14. And we write y. Now let's go only to the numbers that are there, plus 3 and plus 8. So plus 3 plus 8, signs are the same. So 3 plus 8. So signs are the same. Put the same sign and add. That makes it 11. So this is our final answer, 4x minus 14y plus 11. Question 5, again, look out for the like terms. Let's put all the like terms together. Here we have 3x squared, so let's write that. Look out for another x squared and you will find it here. So that is plus x squared. Then take xy, 5xy. See if there are any more xy's. There is one more here, minus 8xy. Then look at the y squares, minus 4y square minus 5y square. Now let's begin by working on the like terms. So this is 3x square plus 1x square. So that is 3 plus 1 makes it 4x square. Let's take the y's. So here we have the y's here. Look at the signs. One is plus, one is minus. When signs are different, put the sign of the bigger number and subtract 8 minus 5. 8 minus 5 is 3xy. Let's go to the last one. This is minus 4y square minus 5y square. So look at the signs. Signs are the same. So we put the same sign. And we add up both these numbers. We have to add up the numbers. 4 plus 5 is 9 and we write y square. So we have a final answer, 4x square minus 3xy minus 9y square. We will stop with that for now, children. In our next video, we will continue with the remaining questions. Thank you, children.